So anyway, thank you all for coming to my talk. Uh, Steps to take until you remove all the rest. My name is Adam Greenberg. I'm a mobile engineer at Pinterest. Thanks to everyone also for organizing this, and let's get to it. So quick background about who I am: 16 years professional software development, 11 years mobile, and 4 years cumulative on GraphQL. If you don't know what GraphQL is, this talk's going to be mostly about that. So in this talk, like I said, we'll be highlighting how at Pinterest we approach migration from REST to GraphQL on the Android client, and hopefully that pun makes a little more sense now. So quick background about GraphQL. If you are not familiar with it, just get familiar with the terminology. We won't really be diving into too much what it is, mostly kind of the migration and the client migration, because that's probably what most of you care about. So GraphQL is a client-driven query language for APIs. And the analogy people love to use, which I think is great, is that REST, if you're familiar with it, I'm assuming most people are, standard IO for years and years and years, but it's like a restaurant menu. So if you allow this comparison, basically every feature needs a new menu item. The client chooses one, the server prepares the dish, and then serves it to the client. And you can make small changes, obviously, like you don't like ketchup, you're not getting ketchup, but you order a hamburger, you're getting a hamburger, you're ordering a peanut butter and jelly, you're getting peanut butter jelly and bread. You might have some slight modifications, but basically you prepared the dish on a predefined recipe. Whereas GraphQL is like a buffet. The server makes all client, and the client takes exactly what it wants and nothing more. Everything is served in one course. Also, so basically, there's this one endpoint where all the items are on the menu. You want dessert, you can get dessert with your entree. You build your salad basically however you want it. All those sorts of specifications are up to you to choose. And you want to get dessert after you get like 3 helpings of mac and cheese, you can go ahead and do that. So terminology a little further, just to make sure that some of these things are kind of known. The schema, which is basically the heart of GraphQL, it is a shared artifact among the server and the client, and it serves as this contract for communication. It's not executable. It's more like a configuration than code, and anyone can look at the schema to learn what it contains. The other part of it is that it is self-referential, so you can introspect it and refer to it as the types. So conceptually, it's basically just this giant graph. And here's kind of the visualization of what one of our things, of what our schema was in its infancy. So this is like in the beginning of it. With GraphQL, basically we can generate these visualizations like this dynamically from the schema to understand how all the data is connected via this graph. Types and fields are basically the backbone of the schema, or sorry, the meat of the schema. The GraphQL types describe the shape of the data that's available. These are basically the fields that are basically making up your object. If you're thinking about this in REST terms, so GraphQL type objects are composed of fields. Every field has its own type, and all data in GraphQL is either a scalar or a composite type derived from the schema. So in a sample like we would see at Pinterest is a Pinterest user is a type user. You have the identifier, the username, and some sort of avatar URL, and some sort of pin content found on the web. You have your pin, your string ID, URL, title, number of likes, and the author, the self-reference to the user. So the type typically describes the URL GraphQL schema and conceptually can translate it into many different languages. And then finally, in terms of the terminology, queries and mutations. So the GraphQL query is described of the data client that wants to receive from the server. And basically, a query conforms to the shape specified by the schema. Queries contain arguments and inputs other from the client. And a mutation is a query meant to modify state on the server. You can think of it almost in an essential that like queries almost analogous to get. Mutations are post-put. I mean, in reality, they are those things, but you can kind of think of it that way if you're trying to talk between the two. Like I said, with our GraphQL journey at Pinterest, we went through backend migration, API exposure, and then finally this client migration, which is what I'll be covering today. Just some quick migration stats, just to let you know the scope of this. So we have over 5,800 fields that were migrated to, sorry, it should say, apologies, it should say 878 unique Android endpoints. We're operating with 459 million monthly users. And our platform engineers who did this whole thing were three of us. So we were basically going through all of this full speed change, trying to change the engine while the car was running. Before we dive into a little further, also want to touch on the frameworks we are using for this. We are using Apollo Kotlin, which is a strongly typed caching GraphQL client. I shouldn't eliminate the Java part because they are full Kotlin right now, Kotlin multi-platform. That's why it's called the Apollo Kotlin. Um, and the benefits of this, just some quick ones I listed. I think I want to say, I'm just going to plant the flag and say that it is probably the first class client. I've seen most engineers using it on Android, but it gives us all of these things. Basically, the main things are the code generation, permutation and subscription, and basically HTTP caching, normalization, which we'll talk a lot about today, these persisting queries, file uploads, and then a lot of test support tools in it. And it gives us kind of this non-immutable data, also the ability to enable this is basically the model layer for the application, which is really nice. So basically, what does this mean for us? So here's a sample query you might see taken directly from the Apollo website where we want this hero, names, and they have a friend type with the ID and the name. And it gives us this very nice class that's automatically generated. It's a little more complex than this, but basically it's giving us this nice kind of data class, which is modeling very close to the query that we're built, automatically generated. We can use this to model kind of the response and then go from there. So the client migration. A quick note, this is more relevant for people who are on the back end with sort of things, but Android, iOS, and the web to some extent don't have these resolvers available that the backend folks do that help us map these fields from REST models to GraphQL and vice versa. So the backend knows how they all relate to each other. Like you saw that giant graph, they're all well aware of how things pair with each other. And kind of what this means is that when you're doing the migration, in REST, we have this thing where you have a typical user screen A and you have some other user screen B. And the data for user screen A, you receive it, you take it, and you pass it over to the user screen B. They can mutate it, they can change it, they can adapt it to the view model. And typically, we like to do extra data flow, so they might copy it and modify it for its needs, but the model is equivalent to the model. You can assume the same types, fields, data, all that information is there on the same user data. But with GraphQL, your user screen now only has the data that that screen needs. If that screen doesn't need specifics, you don't have that, and therefore you don't request that, you don't use it because you don't want to fetch more data than you need to. Uh, and when you try and pass it over to user screen B, there's no assumption because the models are no longer equivalent. And so that poses a huge problem because we now have these things that we used to be able to share that we can't share. And so, the problem becomes how are we creating these reusable components? How do we handle interactions, subscriptions, observability, and statefulness? And then as a platform engineer, how do we handle all of this quickly and efficiently in a repeatable pattern? Um, and so just a quick note that it becomes this big problem when you think of it in a more complex app, where like migrating a single surface is really relatively straightforward. Regardless of the scope of work, platform components can be changed to work with GraphQL paradigms, and Apollo Kotlin does a lot of that heavy lifting, which is why the library is so nice. However, our surfaces don't live in isolation, and so the general and our first approach that we took, um, much like my dog learned to skateboard, we all had to start somewhere. And I always throw this in because in case I bomb, at least you remember me for having the cute dog with the skateboard. But we all have to start somewhere when we're trying to adapt this thing through. So, what does this look like? The general approach is to define your domain models, expose a store API or a shared way to access these fields between both REST and GraphQL representations, abstract the data source to your UI and rest of your app, and then decide to switch between the REST and GraphQL in that layer of the app. And so what we kind of did with this first approach was here's a simple user we had. We did some sort of annotation processing where we would kind of build these abstractions automatically. You can see the fields, the serialized fields I'm sure you're familiar with just any sort of serialization software, library that'll serialize the value we have. We have some sort of about, we have this email object. And we had some sort of mapping that would help us map between the objects, and then we had a standard string. And so what we were able to do is we would use that to generate something that would help us actually like build the map between the two places where we got this now generated user data um, versus a standard user. And we were able to kind of interrupt between that. And so this didn't work for us because it was adding these additional layers. And our goal is to remove all the REST models from the application. And it ingrained so much continued support for it. It ingrained fields that had no longer use. If there was something that was kind of crazy, like the email had been a single field and it should have just been a string. And so we changed that. It hardened us to keep that support for that email object. And the sheer number of classes which needed to be abstracted was just tremendous. So for example, in our app, there's over 100 surfaces which have some variant of the user model. And it just was like, now we have this crazy amount of abstractions between each of the layers. There's no simple way to handle conversion between models. We end up with this one to n number of converters for REST to GraphQL, and this end to n number for converters between GraphQL to GraphQL generated objects. And then last, there were just these multiple points of failure. So when a model changes, the code needs to update for all converters, mapping pieces between converters, and potentially any consumers of them. Also, we're not sure if the breakdown occurred in the IO, if layers, if it occurred somewhere between like the actual passing of the data, or where exactly that occurred. However, like mileage may vary and abstraction might work for you because this is a very common pattern. We've spoken to a number of companies who have been successful with this, and we've spoken to a lot that have not. We were not one of those. So our current architecture, like I said, we decided against abstraction to not force those extra layers. So the surfaces which consume GraphQL run wholesale GraphQL logic from data request to the presentation layer. But still, like I said, this descoped our problem of how to run experiments and migrate from REST to GraphQL since we're not intermixing the logic. However, like I said in the beginning, your surfaces don't live in isolation and they're going to need to communicate between each other, surfaces, components, data stores, etc. So we used Apollo Kotlin, like I said, and in doing so, we gave them most of the heavy lifting. Um, and even if you don't use Apollo Kotlin, these concepts and principles can be used by anyone. They're not tied like completely to the model. It's mostly kind of what we're doing as a guide and principle that we just are able to do with Apollo Kotlin as a base. And so in GraphQL, what one of the main things like I talked to and I touched just a little bit on was this concept of a normalized cache, which breaks down each of your individual GraphQL operation responses into the object it contains. So here we have a query for getting your favorite book, which contains an author object. Then each object is cached as a separate entity based on the cache ID, which means that if multiple responses include the same object, that object can be deduplicated into a single cache entry. This reduces the overall size of the cache and keeps your cache data consistent and fresh. You can also use the normalized cache data as a single source of truth for your UI, enabling it to react to the changes in the cache. So taking that query, we can see that basically we get that response from the query. It's the same shape as the query request. And then finally, we're normalizing this. So you can see that translates to this normalized entry point in basically our cache based on the favorite book author, query root, based on a mapping of the reference and the query book type name. So if we look at something like basically our example of this user object we had before, we can now see that the data class representing the users can be normalized into that single cache entry in this manner. Fairly simple. And we can look at that piece and basically see how that maps to now this REST object. There's difference, obviously, where the UID maps to ID and email maps to this email object where it was a string in the GraphQL response. But we can get a picture now between the normalization of how we can go from one object to the other without having to build a ton of converters through this process of normalization. And so when we look at the normalized non-GraphQL query, it's still kind of the same shape where we have this additional object where this user email exists, but we still can see again that like we have this space where we can see kind of all of these things appearing and how the normalization process kind of can show us a breakdown for some sort of representation on the client side between these two objects as they're fully hydrated. And so from the docs, I kind of went over this before, but it bears repeating that with normalized cache and properly configured cache ID, any updated type is automatically merged with the existing cache item that was returned from a query on that type. So we extended that to note that if we took a query on a type and all fields, any type update is going to update all the fields if we create some sort of God query. And so it's a lot of words, but what this kind of looks like is better represented by these two queries. So say we have two queries now, favorite book and just some sort of book, right? And we take those two queries. What our God query becomes is all the fields that basically are shared in both queries. So we have that list of fields that are all shared, and then all the fields used in all the queries, as well as the author object was included by the author field. So this allows us to get this picture of this giant God query. And when we take that and we look at this where in comparison to the REST book model, now we can note that there's this nice correlation between the two of them, where we see a lot of the same values, a lot of the same things appearing, um, and they start to kind of come together in this way. And we see these junk fields too because we no longer need them. And so now we can basically take that principle from the God query going to the um, REST object, because we know that the God query has all the fields that are possible on that type, and the REST object has all those fields that are possible, but our normalization now knows how to basically say like, hey, we got a subset of the God query, but we can still update that God query in the normalized cache. And so now all we need to do is create a converter interface from that one single place. So we now have this one-to-one relationship where we have a REST model and we have a type, and now we just need to convert between all the fields in one and all the fields in the other instead of multiple converters. And so this is getting into some of the Apollo code, but now we can hook it into this Apollo code. And basically what we're doing here is we're hooking in a callback to our own system where we're passing in the information that needs to get extracted in order to convert the REST object. And this is real code, but it might vary in your own applications. It might vary on how you're doing it. It might vary on how you're keying on the cache, basically. And so once we get that information and we can basically see what the type is, we can launch more logic to convert the actual conversion noted at the bottom in bold, where we're basically getting the normalized entries and then pushing our converters that are previously registered via some pattern via the same key to basically identify the types in the cache. And it's fairly simple. Each field as a standard in in a GraphQL has a type name, which generally corresponds to some sort of object. Like, for example, the user would have been a type name. And if we use a unique identifier, we can basically key on that register, look up these converters, and then basically notify anything once we do the conversion, since we now have this. So in practice, again, this is basically what gives us a superpower. We're looking at the type name, finding the object converter, and then basically using that to map between the God query and the REST object and the REST object and the God query. And so we're basically going again to pull from that cache now, normalize it, and then convert to REST. And so once we convert to REST, we have the successful continuation that I listed just for fun. And basically what it looks like in practice is more like this. So we're converting to REST with this user. We pass in the data model. We have this basically node we traverse, and then we're basically pulling out via the conversion, which is mapping these fields one to one. We have code gen options and hand rolled options, but basically it allows you to just basically make this one-to-one conversion. And so we found something, we pass it in, and now we get a user object that's the REST object, and we can go on our way. So of course we have that down, but let's do it in reverse. So we flip that process now. It's basically to go from any Apollo system updates to REST. And so what we do is we baked in this thing called the connection object, which has our repository layer, the name of the type name that we're using, the REST model converter, the Apollo REST model converter, and the node query, which is the actual query that contains all the fields of types of any given ID. Again, that God query. And we create a callback in our existing system. So when data is propagated outward or a successful update and object completes, all those pieces gets notified. And so in practice, what we have is a simple like user connection. So in a fully functioning system, it looks something like this, where we register the repository, the Apollo type name, node is the user object, the user converter, and then our node query, which is that giant user God query, keying on the node ID. So in that fully functional system, again, that connection, we're walking through it piece by piece. So we start by getting that node identifier. Once we have that node identifier, we can use that connection to look up a specific query object's connection, which generates this node query with all the fields of a given type ID. Once we have this query, we can now take that and then use that converter to take the REST model and convert it to the GraphQL model, because we now know how to go from that REST model to the God GraphQL model. And then we're taking that converter again, repository change, plugging it in, and outcoming with the query data. And so seeing this, we're basically now we have this query object, we need to normalize it to put it into the cache. And so once we do that, we're able to normalize it, take all the entries that are now normalized, put it in the cache. And now what this will do is it'll automatically push any notifications to any watchers on that cache. So basically anything in that cache can now be notified when it's updated, and any of the Apollo objects or anything that's a subset of that God query or equivalent to all the fields in that God query knows that something was changed. And they can take those fields, normalize it, populate the data from that, and then get an update from that information. So again, what we happen is since all of the fields are available here in this God query object and converted to, all objects in that subset are alerted of that change. And so everything basically now that came in from REST is now alerted and updated of that change. So some quick plans for the future. We still have this little bit of this end-to-end problem, and these changes allow us, what I said, to basically solve the bulk of the interop problems, but we kind of glossed over how the end-to-end problems are how we notify any Apollo to Apollo changes. And we're delegating this to developers so they're responsible for listening to fields they care about and notifying it via the watchers. So basically, this involves them actively watching the cache, which is done in the same way that you would watch any sort of cache, whether it's a memory cache, a SQLite database, or just kind of some sort of hybrid between the two. But basically, we feel this is the way to go since it inculcates the GraphQL mentality that developers should be aware of all the data and they request it at all points in time. But we are seeing some pushback where people just want to be notified when something changes instead of having to reinvent the wheel on this. So we may work on building some sort of normalization secondary stage to map between Apollo to Apollo objects or these GraphQL to a GraphQL objects. And with that being said, I know I kind of blasted through everything. Hopefully you got all the concepts. And I am here for some questions.
Hello, thank you. I hope the background music is okay. My wife there's no separation between where my wife's listening to her music, but thank you so much.
I love it.
That was like a proper advanced talk on GraphQL. Very lovely. I haven't. Yeah. Thank you, Adam. So we're gonna give everybody a couple, like another few seconds, or let's give it a minute to write some questions if they have any. Ooh, you already got one. Sweet. If you'd like to start reading them, you can, or we can give people a little bit more time to write them so that they can listen to you while you're answering the others. So Adam, you're in San Francisco?
Yes. Yeah.
So I was talking to Pablo, one of the other organizers here earlier, and he said he felt a bit of a shake, and then we found out later there was an earthquake. So was
Yeah.
there?
5. I think it was 5.1. I didn't feel anything. My wife was at home asleep, so she didn't feel anything either.
Just rocked her back to sleep if
Yeah.
she almost woke up.
Yeah.
Is a 5 too low to really be like alarming?
I think so. I mean, but I'm jaded 'cause I've lived here for a decade now, so
You need like a full tsunami to start caring.
exactly. I think the official thing is when stuff starts falling, that's when it's active.
That's it's a valuable characteristic to be attentive of. Yeah. Okay. Seems like QA is the one question. I'm gonna let
Okay.
you handle it, and I'll turn off.
Yeah. Let me ask you a quick question. Is there a way to get more information? I was gonna say, Coleman, so you're saying it sounds like a slow way to migrate. If your API is small enough, would you recommend doing it all in one shot? Can you clarify? I don't know. Is there a way to clarify if you're saying like the collection of APIs are small enough? Possibly. Um, yeah. I would say it's really up to you. This was more just for what we found, right? So if you're not finding that you have a ton of these like issues where you're really going from one to the next to the next to the next, using kind of the same data and propagating it forward, or really cared about cache data. Like for us, it became really important to keep the cache data in sync. And this was just one of the ways we did it because it's so important, right, to have that data for us quickly and available and in sync, right? And so instead of being like, okay, now we are on a screen and we modified a user object and now we need to convert it, shove it into the repository, and then come back. We had this automatic way to do it that basically anyone can now go and create a new GraphQL screen, replace the old one, and know that any changes they make to the user will be propagated throughout the app. And so it was more of that. But if it's small enough, you may not need it. Like I said, this is kind of a mileage may vary. Something I thought was really cool because I tend to thrive also and panic on the like big question problems where I'm like, oh yeah, migrations can be done even though they're massive, they're semi straightforward, but how do we live with these frameworks that actually make other developers' lives easier?
Okay. We have our answer. Thank you very much, Adam. Wait, we have a message in the chat. Just checking if anything. Oh, we got a
Okay,
thank you
cool.
for answering the question, I assume. Nice.